Hello everyone, welcome to Philosopher Mindful. Today we're delving Aristotle's Principles of Logic, the foundation of rational thought. Introduction to Aristotle's Logic. In this episode, we return to the foundations. Before Freud unraveled the unconscious, before Nietzsche questioned morality, before Kant asked what we could know, there was Aristotle. And Aristotle asked, what does it mean to think clearly? This is the story of logic. Not logic as cold calculation, but logic as the discipline of reason. The map for navigating truth, argument, and the structure of reality itself. Aristotle, born in 384 BCE in ancient Greece, was not just a philosopher, he was a system builder. He didn't write poetry or paradoxes, he wrote systems, categories, structures. He wanted to understand how the mind works when it seeks truth. And at the core of his system was logic, a toolkit for reasoning, for argumentation, and for truth discovery. Why does this matter? Because without logic, philosophy becomes poetry, law becomes chaos, science becomes superstition. Logic is the bedrock, the grammar of thought. And Aristotle was the first to systematize it. Before him, thinkers reasoned, but he showed how we reason. Before him, arguments were made, but he taught us how to distinguish the valid from the fallacious. In this video, we'll explore the historical context that shaped Aristotle's logical investigations, the structure of the Organon, his great logical collection, his core principles, non-contradiction, excluded middle, and more, how his logic shaped science, ethics, and modern thought, and how it still echoes in the code we write, the arguments we make, and the truths we pursue today. So prepare to enter the mind of the first logician, the architect of rational thought, the philosopher who built the scaffolding of reason itself. Historical context and importance in Western philosophy. To understand Aristotle's logic, we must first understand the world in which it was born, the intellectual landscape. Before Aristotle, in the 5th and 4th centuries BCE, Greece was undergoing a transformation. The rise of city-states like Athens had brought about a flowering of culture, democracy, and debate. This was the era of Socrates, Plato, and the Sophists, a time when rhetoric, persuasion, and the search for truth became central to public life. But in this vibrant and chaotic intellectual environment, something was missing, a clear method. Philosophy was rich with questions, but it lacked structure. Thinkers like Heraclitus and Parmenides made bold metaphysical claims, but there was no universal agreement on how to argue, how to reason, or how to distinguish truth from trickery. The Sophists especially were masters of rhetoric. They could make any position seem plausible, even if it contradicted common sense. They taught persuasion, not truth, and Socrates famously questioned their ethical grounding. Then came Plato, Socrates' student. He brought rigor to the search for truth, building his philosophy around ideal forms and dialectical reasoning. Yet Plato's vision was still deeply metaphysical and intuitive. He believed that the world of senses was deceptive, and truth could only be accessed through the intellect. Enter Aristotle, Plato's student, but also in many ways his opposite. Aristotle's radical turn toward empiricism and structure. Aristotle believed the truth was not hidden in a transcendent realm, as Plato thought, but found in the world around us, in the objects we see, the patterns we observe, the language we use. This shift was monumental. Aristotle turned his attention not just to what we think, but how we think. He asked, what are the rules of valid argument? How can we organize knowledge? What principles underlie all reasoning? In short, Aristotle was not satisfied with intuition or inspiration. He wanted precision, classification, and demonstration. He began building the first systematic treatment of logic the world had ever seen. Why logic mattered then and now? Aristotle's project was not abstract. It was deeply practical. In a society where public debate shaped politics, ethics, and education, having a method to reason clearly was revolutionary. He gave thinkers a way to test the validity of arguments, avoid contradictions, categorize types of reasoning, inductive versus deductive, construct persuasive yet truthful statements, and in doing so, he laid the groundwork for centuries of philosophical, scientific, and theological discourse. Without Aristotle, there is no formal logic in the Middle Ages. No scholastic debates, no Renaissance humanism grounded in reason, no Enlightenment, no scientific method. Even computer science and coding logic today carry his fingerprints. He didn't just contribute to Western philosophy, he built its infrastructure, legacy, and longevity. For over 1,000 years, Aristotle's logical texts were considered the final word on reasoning. Medieval scholars referred to him simply as the philosopher. His works were translated into Arabic, studied by Islamic philosophers like Averroes and Avicenna, then reintroduced to Europe, where they shaped thinkers from Thomas Aquinas to Descartes. His influence persisted into the modern era, until the rise of symbolic and mathematical logic in the 19th and 20th centuries. Yet even today, his basic insights remain foundational. The idea that contradictions are fatal to arguments that things must either be or not be, no middle ground. That truth emerges from structured, consistent reasoning. In an age of misinformation, rhetorical manipulation, and social media debates, Aristotle's logic offers not just a tool, but a lifeline. It reminds us that reason has rules, and those rules matter. Core logical principles. The foundation of rational thought, Aristotle's system of logic, as presented in the Organon, rests on a set of fundamental truths, axioms that cannot themselves be proven, but without which no reasoning would be possible. These are the bedrock principles of classical logic. Every valid argument, every coherent statement, every philosophical or scientific inquiry assumes these laws, even if unconsciously. Aristotle did not invent these principles. He discovered and articulated them, made them explicit, and showed how everything else in logic depends upon them. Let's now explore the core logical laws. The law of non-contradiction, the law of the excluded middle, and the principle of identity. These are not just rules, they are the preconditions for rational discourse, without which language, knowledge, and even thought itself would collapse. The law of non-contradiction. It is impossible for the same thing to be and not to be at the same time and in the same respect. Aristotle, Metaphysics, Book Gamma. This is the most central and sacred law of classical logic. It states that a proposition cannot be both true and false in the same context. In other words, if Socrates is mortal is true, then Socrates is not mortal must be false, at least at the same time, in the same sense. Aristotle regarded this law as the foundation of all knowledge and discourse. Without it, he argued, we would not be able to make any meaningful statements at all. If contradiction is allowed, then everything is true, and therefore nothing is. In Metaphysics, Aristotle addresses critics who might try to deny this law. But he cleverly points out, even the act of denying it proves it. Because to make a denial, one must assert something rather than its opposite. Even the denial of contradiction relies on non-contradictory thought. This law also underpins coherence. If contradictions were allowed, then nothing could be logically derived, no argument could be sound, no science could progress. Today, even in advanced systems of thought, like computer programming, mathematics, or scientific logic, this law is implicitly assumed. It ensures consistency, the first virtue of any intellectual system. The law of the excluded middle. For any proposition, either that proposition is true or its negation is true. This is the law of the excluded middle. It states that there is no middle ground between a statement and its negation. In symbolic terms, for any proposition, P, either P is true or P, not P, is true. This law is powerful because it forces clarity. It eliminates ambiguity in logical discourse. Something either is or is not. You must choose. This doesn't mean that every question is easy to answer, but it does mean that every proposition has a truth value, either true or false. Aristotle uses this law to define the limits of logical space. It structures binary logic, which underlies not only classical philosophy, but modern computation. But it has also raised interesting philosophical debates. For instance, what about future events? Aristotle himself famously hesitated when applying this law to statements about the future. In De Interpretatione, he considers the proposition, "There will be a sea battle tomorrow. Is this statement true or false right now?" Aristotle suggests that assigning a truth value to future contingents may violate human freedom, because if it's already true or false, then the future is determined. This led to centuries of debate on free will, determinism, and the logic of time, showing that even the most rigid laws of logic can touch the deepest parts of human experience. The principle of identity. This third foundational law is often stated as A is A. It seems almost trivial, but it's essential. It means that each thing is identical to itself. That if you say a tree, you refer to something with a stable, identifiable nature. Without this law, language would become meaningless. If Socrates didn't always refer to Socrates, if mortal didn't mean the same thing throughout a sentence, then logic would dissolve into noise. This law enables definition, categorization, and meaning. The interrelation of the three laws. These three laws, non-contradiction, excluded middle, identity, form the tripod of rationality. They are not isolated. They support and imply one another. Identity ensures that terms remain stable throughout an argument. Non-contradiction ensures that opposing claims about a single identity can't both be true. Excluded middle forces us to decide between them. These principles do not just guide logic, they define what logic is. Why these laws still matter in an age of postmodern relativism, emotional discourse, and rhetorical manipulation. Aristotle's logical laws remain a defense, a shield against nonsense. They remind us that clarity matters, consistency matters, meaning is not a mood. Even in contemporary debates, political, ethical, scientific, these laws act as a silent framework. When someone contradicts themselves, we instinctively know it's flawed. That instinct comes from these Aristotelian principles. In science, these laws are baked into the structure of hypotheses, experimentation, and falsification. In mathematics and programming, they're literal. A line of code either executes or it fails. A true-false condition governs every logic gate, and in everyday thought, when we weigh options, argue, persuade, we rely on these laws, even if we've never read a word of Aristotle. Challenges and developments. Of course, not everyone has accepted these laws without question. In the 20th century, non-classical logics emerged, like fuzzy logic, para-consistent logic, and quantum logic, which challenge or modify one or more of these laws. Fuzzy logic allows for degrees of truth. Para-consistent logic tolerates some contradictions. Quantum logic reconsiders excluded middle in light of quantum states. But even these are not rejections, they are extensions. They exist because classical logic laid the groundwork. They depend on Aristotle's insights to define their departure point. And so, Aristotle's laws still rule, not as dogma, but as the foundation of all logical structure. Applications of Aristotelian logic. From scientific method to ethical reasoning, Aristotle's logic, while abstract in formulation, was never intended to remain confined to scrolls or classrooms. For him, logic was a living tool, a method not only for pure thought, but for practical use in the real world. In his vision, logic underpins everything, from biology and astronomy to politics and ethics. This section will explore how Aristotle's logical system evolved into a foundational structure for both scientific reasoning and moral philosophy, shaping how we understand knowledge, truth, responsibility, and inquiry across every major domain of human thought. Logic and the scientific method. Aristotle as proto-scientist, though the formal scientific method as we know it was developed much later, through the works of Francis Bacon, Galileo, and Newton. Aristotle laid down its philosophical and logical skeleton over 2,000 years earlier. In posterior analytics, Aristotle articulates the vision that science begins with what is known and proceeds toward what can be demonstrated with necessity. He believed that all genuine scientific knowledge, episteme, must meet three criteria: be necessarily true, be known through its cause, be derived from first principles. Let's explore how Aristotle's logic contributes directly to what became the scientific method. A. Observation and induction. Aristotle believed in starting from experience, from sensory data, from the world we see, hear, touch. Unlike his teacher Plato, who distrusted the senses, Aristotle believed empirical observation was not only valid, it was essential. He described the process of induction, epigoge, moving from specific observations to general principles. For example, you observe that many metals conduct electricity. You induce a general rule. Metals are conductors. This process of forming generalizations from empirical cases is the first step in scientific inquiry, and Aristotle was one of the earliest to articulate it as a structured method. B. Deduction and demonstration. Once general principles are established, Aristotle taught that reasoning proceeds through deduction, specifically syllogistic reasoning. This deductive process is how science confirms hypotheses. All metals are conductors. Copper is a metal. Therefore, copper is a conductor. This movement from general truths to particular cases mirrors the modern approach in scientific modeling and prediction. C. Causality and explanation. Aristotle was obsessed with causes. In fact, his philosophy is famous for defining 4 types of causes: material cause, what something is made of; formal cause, its shape or structure; efficient cause, the agent that produces it; final cause, its purpose or function. This multi-layered approach to causality deeply influenced how scientists across ages would seek explanatory depth, not just how things happen, but why. It's also the reason Aristotle is often considered the first biologist, first physicist, and first systematizer of science. Though many of his specific conclusions were later corrected, the logical form of scientific inquiry he established remains intact. Aristotelian logic and ethical reasoning. It may seem strange to talk about logic and ethics together. Logic is strict and mechanical. Ethics is human and value-driven. Yet Aristotle saw them as deeply connected. To reason ethically, one must understand the nature of good and evil, the consequences of actions, the consistency of moral beliefs, the logical structure of moral arguments. Let's see how Aristotelian logic plays out in moral reasoning. A. Practical reasoning, phronesis. Aristotle made a distinction between theoretical reasoning, used for science and math, and practical reasoning, the kind we use in real-life decisions. This is governed by phronesis, or practical wisdom. It's not just knowing what's true, it's knowing what to do. Practical reasoning involves weighing consequences, discerning means and ends, and applying general moral principles to particular situations. This requires structured thought, logical consistency and clarity, the very qualities cultivated by logic. B. Consistency and moral argument. Much of ethical discourse hinges on avoiding contradiction. We hold people accountable when their actions contradict their stated values. We challenge policies that violate moral consistency. For example, if you believe all life is sacred, can you support the death penalty? If honesty is a virtue, can lying ever be justified? These questions require the logical tools of deductive reasoning, contradiction analysis, and conceptual coherence, all stemming from Aristotelian logic. C. Virtue ethics and the mean. Aristotle's own ethical theory, virtue ethics, is itself a product of logical structuring. He argued that moral virtue lies in the mean between extremes. Courage is the mean between cowardice and recklessness. Generosity is the mean between stinginess and extravagance. To identify the mean in any situation, we must reason well. We must think through consequences, measure character, and avoid moral contradiction. Thus, logic becomes not just a path to scientific truth, but to moral wisdom. Aristotle's logic in rhetoric, politics, and law beyond science and ethics. Aristotle's logic found deep application in rhetoric, politics, and legal reasoning. In rhetoric, he teaches how to persuade using ethos, credibility, pathos, emotion, and logos, logic. Logos, the logical structure of an argument, is the core of rational persuasion. In politics, he believed laws must be written and enforced based on rational principles, not passions or arbitrary authority. In law, syllogistic reasoning is foundational. All theft is punishable. This act was theft. Therefore, this act is punishable. Even today, judges, lawyers, and juries rely on this structure, often without realizing it. The modern world, algorithms, AI, and programming. The influence of Aristotelian logic doesn't stop at philosophy, science, or law. In the digital age, his legacy takes a new form: binary logic, the logic of ones and zeros, of programming and machine thinking. Modern computing is built on Boolean logic, which is an abstracted evolution of Aristotelian principles. If-then structures, true-false statements, logical operators and conditionals. Every search engine, every AI model, every decision tree is an echo of Aristotle's insight. That thinking can be structured, and structure can generate truth. Conclusion: logic. As a way of life for Aristotle, logic wasn't just a school subject. It was a discipline of the soul, a way to align one's thoughts with reality. It was how the philosopher purified his mind, how the scientist illuminated the world, and how the citizen sought justice. It was the universal grammar of truth, and, though the tools have evolved from syllogisms to silicon chips, the core remains. Aristotle gave us more than rules. He gave us a mindset that clarity, consistency, and reason are the highest virtues in our pursuit of understanding. Modern perspectives, relevance, critiques, and evolutions of Aristotelian logic. As we leave the ancient world and move into modernity, the question arises, does Aristotle's logic still hold? After all, human knowledge has exploded. Science has evolved. Computers, quantum physics, and cognitive science have introduced entirely new ways of thinking. So where does Aristotle stand today? This section will explore both the enduring relevance of Aristotelian logic and the critiques and evolutions that have emerged in response to it. We'll journey through centuries of intellectual development, from medieval theologians to 21st century computer scientists, and examine how Aristotle's logical principles have been tested, transformed, and at times transcended. The medieval world, scholasticism, and the triumph of Aristotelian logic. After Aristotle's death, his works were preserved by Greek scholars, then translated and expanded upon in the Islamic Golden Age by thinkers like Averroes and Avicenna. Their interpretations reintroduced Aristotle to Europe, where he became central to medieval scholastic philosophy. The Christian Church, despite initial resistance, eventually embraced Aristotelian logic, especially through the work of Thomas Aquinas. Aquinas fused Aristotelian philosophy with Christian theology, using logic to systematize doctrine, prove God's existence, and resolve moral dilemmas. For centuries, Aristotle's logic was not just respected, it was canonized. It became the framework through which truth was pursued in universities, monasteries, and courts. The Renaissance and the birth of skepticism, but as the Renaissance revived classical humanism and empirical inquiry, cracks began to show. Thinkers like Francis Bacon criticized Aristotle for being too deductive. They argued that his logic was too abstract and that science needed inductive methods based on observation and experimentation. This marked a philosophical shift from logic first to data first, from syllogisms to hypotheses and experiments. Though Aristotle had laid the groundwork for scientific thinking, his dominance began to wane in favor of methods that emphasized empirical testing over pure reasoning. 3. The Enlightenment and rational. Revolution in the Enlightenment, Aristotle's logic was both revered and revised. Descartes, Kant, and Hume engaged with Aristotelian ideas, either building on or critiquing them. Kant, in particular, praised Aristotle for completing the doctrine of logic, but believed it needed to be restructured according to his own categories of understanding. Meanwhile, Enlightenment thinkers embraced the spirit of logical clarity, classification, and systematization, traits that Aristotle had pioneered. But they began asking new kinds of questions. What are the limits of logic? Can reason fully grasp reality? Is there a place for contradiction? These inquiries laid the groundwork for the philosophical revolutions of the 19th and 20th centuries. 19th century. The birth of symbolic logic, one of the most dramatic shifts in the history of logic, came in the 19th century with the emergence of symbolic or mathematical logic. Thinkers like George Boole, Gottlob Frege, Bertrand Russell, and Kurt Gödel moved logic away from Aristotle's verbal, syllogistic forms toward a formal language using symbols and quantifiers. Boole developed Boolean algebra, the foundation of computer logic. Frege introduced predicate logic, allowing for far more complex statements than Aristotelian syllogisms. Russell and Whitehead attempted to derive all mathematics from logical principles in Principia Mathematica. Gödel famously proved that no logical system could be both complete and consistent, challenging the idea that logic could serve as a final foundation for all truth. This revolution marked the beginning of modern logic as a distinct discipline, often more mathematical than philosophical. Was Aristotle obsolete? Not at all. His ideas remained foundational, but they had to evolve. Just as Newtonian physics was absorbed and extended by Einstein, Aristotle's logic became a special case within a larger logical universe. 20th century and beyond. Logic meets computation with the rise of computer science. Aristotle's influence surged once again. The principles of classical logic, especially the law of non-contradiction and excluded middle, are the basis of digital logic. True, false, becomes 1-0. Logical gates, and or not, reflect fundamental binary operations. Algorithms are structured around if-then statements and quantifiable logic trees. Alan Turing's work in theoretical computing was deeply rooted in logic, and the programming languages we use today are essentially implementations of formal logical systems. Without Aristotle's framework, the very concept of programming, data structures, or automated reasoning would be unthinkable. 6. Contemporary challenges, non-classical and postmodern logics. While Aristotle's principles remain embedded in many systems, they have also been challenged and refined by newer developments. A. Paraconsistent logic. This system allows for controlled contradictions. In classical logic, a contradiction renders a system useless. From PEP, anything follows. Paraconsistent logic asks, can some contradictions exist without destroying logical coherence? Useful in contexts like legal reasoning or quantum mechanics, where ambiguity and duality are part of reality. Fuzzy logic introduced by Lotfi-Zadu. Fuzzy logic allows truth values to range between 0 and 1. Not all propositions are strictly true or false. Some are mostly true. This has been vital in AI, machine learning, and decision-making algorithms. C. Modal logic. This branch extends classical logic to include modalities like possibility, necessity, and contingency. Crucial in fields like philosophy of language, epistemology, and metaphysics. D. Postmodern critiques. Postmodern thinkers like Derrida and Foucault questioned whether any system of logic can fully capture reality. They warned that logic may carry hidden assumptions, cultural biases, or power structures. While not rejecting logic outright, they emphasized that meaning is not always fixed, and that ambiguity can be as revealing as clarity. 7. Conclusion. Aristotle's logic is living legacy. So where does this leave us? Aristotle's logic may no longer be the cutting edge, but it remains the cutting stone, the tool that shaped the very landscape of rational thought. It is the origin of logic as we know it, a tool for truth, a guide for discourse, a method for knowledge, a discipline of the mind. In every valid argument, in every line of code, in every search for consistency, we are still walking the path Aristotle cleared for us over 2,000 years ago. Conclusion. Aristotle's enduring legacy of logic. Over the course of this 2-hour journey, we've uncovered a philosophical structure that underlies nearly everything we think, say, and do. We began in ancient Greece, where Aristotle, a student of Plato, asked the most fundamental question: how can we think clearly? His answer wasn't mystical or poetic. It was precise, analytical, and revolutionary. Logic, for Aristotle, wasn't just a tool, it was the foundation of all truth. From syllogisms and categories to laws of contradiction and deduction, he laid out the world's first complete system of rational thought. And that system did not stay in dusty scrolls. It spread through religion, science, law, politics, and education. It was adopted, refined, challenged, and reimagined across continents and centuries, but never erased, never replaced. Even today, in the digital world of algorithms and AI, Aristotle's fingerprints remain. He reminds us that to live well, to reason well, to speak well, we must first think well. Logic is not just for philosophers or scientists. It is for anyone who seeks truth in a world of noise. It is for anyone who values coherence over chaos, clarity over confusion, reason over rhetoric. And in a time when misinformation spreads faster than knowledge, when emotional manipulation often wins over rational dialogue, Aristotle offers us a shield, a method, a map. If this exploration of Aristotle's logic inspired you, if it made you pause, reflect, or even challenge your own thinking, then join us for more. Subscribe to Philosopher Mindful. We take you deeper than surface quotes. We unpack the minds that shaped civilization, from Aristotle to Nietzsche, from Spinoza to Freud. Like and comment below. What part of Aristotle's logic do you see most in today's world? Have we evolved beyond his principles, or are we still catching up? And share this with a friend who still believes debate is about volume, not logic. Because if you want to think clearly, speak truthfully, and live thoughtfully, Aristotle is where you start. Until next time, stay mindful, stay structured, stay free, would you?